Hello and welcome to our next lesson in this topic looking at the periodic table. In previous lessons we've spoken about what elements, compounds and mixtures are. We've spoken about the general structure of the periodic table, defining what groups and periods are. We've spoken about the group 1 alkali metals. We've spoken about the group 7 halogens, and today's title, we're going to talk about group 0. So in your books, if you could write the title, the periodic table, group 0. By the end of this lesson, you should be able to recall where the elements of group 0 are found on the periodic table. You should be able to describe the trends of group 0 elements, and you should be able to predict the properties of group 0 elements. So we'll start with a keyword. Our keyword is group 0. That's the worst U ever. Group 0. I'm also going to put /8 because on some periodic tables and in some questions they also refer to group 0 as group 8. It's the same thing, okay? So group 0 and group 8 are the same thing. So we can define group 0 as the far right column or group of the periodic table. Okay. Now, the group 0 elements are also known as the noble gases. Okay, so also known as the noble gases. Now, because they are on the far right hand side of the periodic table, they are therefore classed as non-metals. Okay, so group 0 elements or group 8 elements are on the right hand side of the periodic table so are non-metals. Okay, now if we were to look at a periodic table, group 0, or the noble gases as they're known, would be found in this far right hand column. Okay, the noble gases include the following elements. So we can say the noble gases include ... We've got helium, we've got neon, we've got argon, we've got krypton, we've got xenon, whenever we use an X we pronounce it as a Z, so it's xenon, and we've also got radon. Okay, so the group 0 elements or the group 8 elements are on the far right hand group of the periodic table. They're also known as the noble gases. They're in the far right hand group, therefore they are non-metals. And the noble gases include helium, neon, argon, krypton, xenon and radon. Okay, this is a video, so you can pause it if you wish to continue making notes. So, as we've done for all the other elements, we need to now think of the physical properties of group 0. So we can put the physical properties of noble gases. Okay? So the physical properties of noble gases. And just for our reference, as we always do, I'm going to put a periodic table over here so that we can refer back to group 0. I'll probably make it a bit bigger than that. And it doesn't matter if it goes behind there, does it? So, group 0 is helium, neon, argon, krypton, xenon, and radon. Okay? If I was to get a table of the boiling points of the noble gases, it would look like this. Okay? As we move down group 0, the boiling points increase. However, the noble gases in general have very low melting and boiling points. So we can say, I'm going to put in red, that the noble gases, in fact I'm going to put it down here, the noble gases have very low melting and boiling points. Okay? We said, and I'm going to write here up at the top, that as we move down group 0, their boiling points increase. So we can put an arrow and say, as we move down group 0, or 8, depending how you look at it, 0/8, boiling points increase. Now, the reason we say increase is because, remember, this is a minus value. We're getting closer to 0. So it's actually going up. Okay? Now, the noble gases are colorless gases at room temperature. Okay? So at room temperature, they are a colorless gas. So the noble gases are a colorless gas at room temperature. Okay? Now, when we pass a high voltage electrical current through the noble gases, they shine brightly. Now, this is really useful for things like shop signs. Shop signs contain the element neon because as you pass an electrical current through them, it starts to shine brightly, such as this open sign shown here. So we can say that the noble gases glow brightly when a high voltage electrical current is passed through them. comma, making them useful as shop signs. Making them useful as shop signs. So this one here that's shown on the diagram is neon. Okay? So this element, neon, is found in the shop sign. When we pass an electrical current through it, it shines brightly, indicating that the shop is open. At the same time, the noble gas helium has a much lower density than air. And that's why it's used in helium balloons, so that the balloons float. So we can say, if I can fit this in somewhere, up to there, we can say that helium has a lower density than air, comma, so is used to inflate balloons. Okay. Finally, argon, which is another group 0 element. Argon is a better insulator than air. So we put argon between double glazed windows, the gap between the double glazed windows. So argon is a better insulator than air, so we put it between double glazed windows. So argon is a better insulator than air, and is therefore put in the gap between glass in double glazed windows, between glass in double glazing. Okay, so the physical properties of the noble gases, or the group 0 elements, that you need to know about is that as we move down group 0, their boiling point increases, but the noble gases in general have a very low melting and boiling point. They're a colorless gas at room temperature. They glow brightly when a high voltage electrical current is passed through them, making them useful for shop signs. Helium in particular is a gas that has a much lower density than air, and we can put it inside balloons to make them float. And argon is a better insulator than air, therefore we put it in double glazed windows. Right then. Final bit for today. We need to talk about the chemical properties of the noble gases. The chemical properties of noble gases. Now, one thing that you need to know about the noble gases is that they are highly unreactive. They are very, very unreactive. So we can say that, and I'm going to put in regs, it's important, the noble gases are unreactive. Now, what we mean by the term unreactive, we can make that a key word. The word unreactive, so all keywords are in green. The word unreactive means that it is an element or elements that take part in very few chemical reactions. Okay? So they are elements that take part in very few chemical reactions. Now, as far as we know, helium and neon never take part in any chemical reactions. So helium and neon, if I can get my periodic table back, helium and neon, which are at the top of group 0, never take part in any chemical reactions. So we can say that helium and neon never take part in chemical reactions. Now, in the year 2000, Finnish scientists made the compound argon fluorohydride, but it only existed at temperatures of minus 265 degrees Celsius. So what we're saying there is that argon didn't really take part in any reactions until 2000, when scientists made this argon fluorohydride. Okay? So argon fluoro, FluoroHY, DRIDE, argon fluorohydride only is made at minus 265 degrees Celsius. Full stop. This wasn't discovered until 2000. This wasn't discovered until 2000, the year 2000, 21 years ago. Now, krypton reacts with the most reactive element, fluorine. Remember, fluorine is found in group 1, to make krypton difluoride. So, krypton only reacts with fluorine, I have to check that I spelled fluorine right then, and we can put in brackets the most reactive element to form krypton difluoride. Okay? Or KRF2. Don't know what I'm doing there. KRF2. Okay. Xenon is very unreactive, but it does form compounds with fluorine and oxygen. So we can say that, which colour can I use? Xenon is unreactive but does form compounds with oxygen and fluorine. Okay. Now, most noble gases are found in the atmosphere. They're just part of the mixture that we call air. We can use distillation to separate them from the air to get things like helium that we can use. Okay. So I'm going to put here, I'm going to put it in red, that noble gases are found in the atmosphere. Full stop. We can use distillation to separate them from the air for use. To separate them from the air for use. But also at the same time, helium is found as a natural gas underground. So helium is found, I'm going to do that again because that looks terrible. Helium is found as a gas underground. So, the chemical properties of the noble gases, they are unreactive. Unreactive elements are elements that take part in very few chemical reactions. Helium and neon have never taken part in any chemical reaction that we're aware of. Argon fluorohydride is only made at minus 265 degrees Celsius and was only discovered in the year 2000. Krypton only reacts with fluorine, which is the most reactive element, to form krypton difluoride. And xenon is unreactive, but it does form compounds with oxygen and fluorine. The noble gases are found in the atmosphere as part of the air, which is a mixture, and we can separate these gases from the air using what's known as distillation. Helium is also found as a gas underground, but helium is also found in the air. Okay, helium is found both underground and in the atmosphere. So, you should now be able to tell me where the group 0 elements are found on the periodic table. You should be able to describe the trends of the group 0 elements, and you should be able to predict some properties of group 0 elements. Should you have any questions at all about this lesson, please contact me via the usual means. If not, I will see you in the next lesson. Thank you very much.